How to graph y equals 1 over x, part 2 of 2. This is Tom Reardon, math teacher from Ohio. You will need graph paper and a pencil. Press pause anytime as needed. Let's summarize what we know about the graph of y equals 1 over x so that we can know how to graph this by hand. First of all, it's called the graph of the reciprocal function. The shape of the curve is called a hyperbola. The curve has two parts called branches. So two branches of the hyperbola. The x-axis and the y-axis serve as boundary lines for the graph, meaning the graph gets close to those lines but never actually touches them. So here's the x-axis in dotted green. This is called an asymptote. We don't use the word boundary line, but so it serves as one. We call it an asymptote, spelled a little bit peculiar. And it's also the equation y equals 0. The dotted brown line is also called an asymptote, the y-axis, and its equation is x equals 0. So those are the asymptotes for this. And we're going to call the origin the center of the hyperbola. We have a place like to start, and you'll see that when we go to graph it. So how to graph y equals 1 over x using the reciprocal dance? First step is to identify the center point, which in this case is the origin. And then from there, we plot 3 key points in the first quadrant. Right 1, up 1, because 1 and 1 are both reciprocals of each other. Right 2, up a half. 2 times a half is 1. And right a half, up 2. So those 3 points kind of show how the curve goes. We can do 3 more points in the third quadrant. Left 1, down 1. Negative 1 times negative 1 is positive 1. They're reciprocals. Left 2, down a half. And left a half, down 2. So we have 6 points from that center point. From here, we're going to draw the horizontal and vertical asymptotes as dashed or dotted lines and label their equations. So we've got the x-axis here, which is really y equals 0. And we've got the vertical y-axis, which is really x equals 0. And we want to draw the curve, connect the points, and extend. So a little bit shaky there, sorry about that, and a little bit shaky here, but we'll go ahead and make it look a lot nicer. But remember, as the curve is extended, it gets really close to the asymptotes, but never actually touches it. It's important to realize that. So the curve, pretty, looks like this, and this is what we would hope your graph looks like when you graph this. So to review, just to summarize this, you do need to identify the center point when you go to draw the graph of a hyperbola. You need to plot 6 points, 3 in the first quadrant, 3 in the third quadrant. Those kind of get the shape. You need to draw in both of the asymptotes and label their equations. That's important. And then draw the curve, careful not to touch the asymptotes. Beautiful. Yes, beautiful. And finally, let's look at the domain and range. So the domain, if we look at all the x values, it looks like we can use every single x value except 0. So it's going to be all real numbers except 0, and this is how we write it. The set of all x such that x is a member of the reals. X cannot be 0. And the range, all the y values are accounted for except for this one where y is 0, the x-axis, okay? So it's really the same set, we just write it different because it's range, set of all y such that y is an element of the reals and y cannot be equal to 0. Where can you see hyperbolas in the world? We thought you might find this image kind of interesting. We encourage you to interact with other videos in this series.